Welcome to Saxon Algebra 2, Lesson A. That is so unsatisfying, isn't it? Lesson A, come on, we want Lesson 1. But this book, for whatever reason, starts with a Lesson A and B that are chock block full review lessons. So the good news is we're going to start out with a really strong review, and it'll be somewhat relaxing to work through some problems that you're familiar with. Before we dive in, let me just tell you who all we have gathered here. We have Abby, Micah, Kyle, who studied Algebra 1 with me last year, and we're adding in Eva, who did not study with us last year. So welcome, Eva, to our happy group. You guys all go to Westgate Academy together, so you'll meet each other there. Someday we all may gather and sit around a table together, and I look forward to that day. But for now, we get to study through video. So here we go. Are you ready? We're starting by defining some terms. Geometry, by the way. Point, curve, line, and plane. You've seen all those words before, I'm sure, in real life, not to mention in your math life. And the really fun thing is that John Saxon, who wrote the textbook, John starts by telling us these are something called primitive terms, which means they're really clear ideas, but they're hard to put into words. Story of our math lives, right? So it's possible to understand exactly what this is without being able to really explain it. So I'll do my best. A point is a location. When you put a dot on a piece of paper to mark a location, the dot is not the point because it's bigger than that, right? If I do that, that looks like a point, but that's actually bigger than a point. A point is tiny, tiny, tiny. But that conveys the idea. A curve is an unbroken series, both a curve and a line. They're an unbroken connection of points. Excuse me, Grace wants out. I'm sitting right by the door, so just a second. Have fun. Good girl. It's another one of those smoky wildfire days, so I feel like I should put her in a little fireman's suit before I send her out there. There's not a fire in my backyard. Why would I say that? It's smoky, that's why. Unbroken connection. A curve bends, so it can be bending, or, in the case of a line, perfectly straight. But the idea is that it's all these tiny dots connected together that make a line or a curve, right? For any 2 points, there's one line that connects them. We can also talk about line segments, because we know that a line goes on forever, right, to infinity and beyond. But we can talk about a particular section of the line. We define it with some sort of dot or marking, and that is called a segment. We often give these letters and designate them in writing like that, a little line over their heads, right? So we can talk about line AB, which would be like this, if we mean the whole shooting match. Or we can talk about segment AB. Either one would be designated this way. We can also write the letters in the opposite order, but I just don't even like that. Array is sometimes thought of as a half a line, which may or may not make sense to you, but the idea is that it has an end point on one side and infinity on the other. And we can do the same thing with arrays, where we can write them by drawing a little picture above their heads. All right. A plane, which we have up there, is a flat surface. It has no thickness, right? It's like the thinnest plate of glass, but it goes in 2 dimensions, okay? And we often talk about lines that lay on the plane. Let me just show you in the book, because the pictures illustrate it nicely. I know I'm casting a big shadow across the book, but work with me. The diamond-y thing is meant to be the plane, the 2-dimensional surface, and we can have lines that lie on top of the plane. Now, we could also have lines going through the plane, but we're not talking about those right now. We're talking about lines that lie on top of the plane. And as you can see, there are there's 3 kinds. You can have parallel lines. Those are lines that don't touch ever, they don't meet. So these are all types of lines. We can have intersecting. That's the garden variety line that does meet, or do, because there's 2 of them. They do meet. And then we can have perpendicular. Remember that you're writing down everything that I'm writing down. Pause me. I'll try to go slow. I know this is a lot of writing. Perpendicular lines meet at 90-degree angles. Uh-oh, I think my dog wants back in. Grace, do you want to come in? Do you want to come in? Okay, hang on. Come on. Good little girl. Okay. Nothing like a few pet diversions in the middle of a math lesson, is there? Okay, so parallel lines look like this. Intersecting lines make some sort of an X. Perpendicular lines meet in a perfect plus sign, right? With a little right angle there. Okay, now when 2 lines intersect in one way or another, they form angles, right? So we can talk about the different kinds of angles that are created when lines intersect. Parallel lines don't meet, so they're never going to form angles, but lines that intersect in any way, and particularly those that make perpendicular crossing points, those create angles. So let's look at the different kinds of angles. There's a right angle. That's everybody's favorite. Well, maybe it's not yours, but it might be mine. Those are lovely because they make a nice 90-degree angle. Then we have, ooh, wow, that was really crooked. We have acute angles, which means that all angles are less than 90 degrees. And we have obtuse angles, where one of the angles is greater than 90 degrees. You can't have 2 angles greater than 90 degrees in an obtuse triangle, because remember, they have to add up to 180. So if one is greater than 90, another one can't be greater than 90, because that would add up right there to more than 180. So it's only one angle that needs to be greater than 90 degrees. Now let me make, oh no, these are angles. Draw some little arrowheads on there, because remember, these are essentially rays, right? They have an endpoint in one way, but they go infinitely in others. So that's just to remind you that we're connecting these ideas. There's a straight angle, which is when basically we create a straight line. You can think of that as an angle as well. You can think of it as being 2 right angles if you want, but the total degrees of a straight angle are 180. So let me write this, straight. And then for any kind of angle that we might have, I'll just draw it like that. If you measure the other part of the circle that's outside of the angle, that's called the reflex. angle. Okay, so we can always look at the other angle that's created when we draw an angle. There's always an outside angle if you want to think of it that way. So there we are. We have our different kinds of angles. The right angle and the straight angle build together. Flipping the page. If we put those ideas together, we can see that within a circle, we have 360 degrees because we basically have 4 right angles or 2 straight angles, depending on how you want to look at it. All right, so that's a circle. Just skimming through the book. There's tons of information in these first lessons, so I'm kind of skimming through for what I think you'll actually need. Complementary angles. If we have 2 angles that come together, there's angle A and angle B, and together they make a right angle, right? A plus B, angle A plus angle B equals 90 degrees, right? We know that because we see that this is 90 degrees. We see that this is a straight line. We see that A and B make up the other right angle in this straight angle. So we can say that these 2 angles are complementary. Not like I give you a compliment, but like this flavor complements that flavor. Different spelling in the word. Then sometimes we have another situation where we have a straight line and then we have 2 angles that go together to make up the whole straight line. Here we can say that angle C plus angle D equals 180, and these are called supplementary angles. These 2 ideas show up a lot in our problems because you can actually do something with them. You can make little equations. The other type of angle that I want to talk about are vertical angles. They show up when you have intersecting lines. No right angles necessarily, but in this case, we can see that the angles that are opposite each other are equal. So angle E equals angle F, and then we'll do this one G, and I'll make these bigger so you can see they're different. And angle G equals angle H. Okay, so whenever we have intersecting lines, that creates vertical angles, and the opposite pairs of vertical angles are equal to each other. Also, super helpful if you want to create some fun little algebra problems to do. So here come 3 fun little algebra problems that use these ideas. I'm flipping to check and make sure I'm still in the boundaries of my viewfinder. Okay, example A1. Yay, our first example of the year. We have a relatively kooky picture. You may be able to just look at the picture and figure out the answer from there, but if these problems slow you down at all, draw them out. It helps so much to notice all the details of the problem by writing them. If I just look at them, I tend not to notice everything. So take your time. Let's see, this one actually should be like this. And this whole thing is called y degrees, and this is 40 degrees. Okay, so we're supposed to take this information and use it to figure out x and y. That's the instruction. Find x and y. If I were doing my homework, I would write this down. I probably wouldn't write that down, but I'm writing that down for you because you're just looking at my page and not the book. Okay, so I can see that, and here's a hint, John almost always makes it easier if you go in alphabetical order and trying to solve these. You could do y first, but it's a good idea to just go alphabetically, and sometimes finding one will help you find another. Not always true, but sometimes. Okay, so let's start with x. X we see is here, and we notice that he's squeezed into this first right angle with 30. So we can see, oh, these guys are complementary. That's the word for when they add up to 90 degrees. So x is going to equal 90, the whole quadrant, minus this 30-degree angles. So x is equal to 60 degrees. Make sense? I box it, just like you will in your homework. Now y, I can see that y and this 40-degree angle, they make up the other side of this straight angle. So I know that y is equal to 180, this full section, minus the 40. So y must equal 140 degrees. Yay. I check my answer. It's written in the book. We got them both right. There's my star and my smiley. If I were doing my homework, I would make those a different color. Okay, another one. I would much rather do problems than define things. I think that's boring. This time we have vertical angles, and we have x, y, and a p. What? P? They have these little markers on them, and this says 50. And then it looks kind of like that, right? Here we're supposed to find x, y, and p. Again, I'm writing this down just so that you can see the instructions. I wouldn't write that in my homework. I would write this. All right, so we recognize right away, oh, this is vertical angles. X marks the spot. And we know that opposite pairs are going to be equal. But we have 3 letters, so that seems overwhelming. Look to where, again, we're going to go alphabetical. That's a good hint. And we're also going to look at where we've got a number, because that will help us. 50, there's a 50. So we know that the angle opposite is also going to be 50. That's x. So we can write x equals 50 degrees. Okay? Cool. I'm just going to write that into my picture because sometimes that helps me visualize how to use it. And in this case it does, because I can see this makes a straight line. There's several ways you can find this next number, but I notice this makes a straight line. So that means that this is a straight angle and it has to add up to 180. So y must be equal to 180 minus this 50, right? Because the other part is all y. So y has to be equal to 130 degrees. And, just a second, let me put some boxes here. And our last one is p. Again, John didn't go alphabetically, but if we follow his order, that's helpful. If y equals 130, then p must also equal 130 because it's the same as y. Those guys are vertical angles, so they must be the same. Double checking. Y equals 130. X equals 50. Yay, we got it right. Okay. One more. But we have another section, so it's not like we're done with this lesson. Sorry. Find x, y, and p again. The picture is vertical angles again. Wait, this goes on the outside. I'm just copying the problem. Okay. Give you a second to catch up. I've told you guys I'll pause me if I'm going too fast so that you can write and not feel rushed. I'm also trying to slow down a little bit and give you more time to write. So between those two strategies, hopefully you will not feel like you're rushing to keep up. Okay, this one's a little trickier because we have numbers in front of our letters and these weird parentheses. The point of the parentheses is just to say that this entire expression is the measurement of the angle, right? It's just to designate that 5x represents the value of this angle and 2x represents the value of that angle. And then we just put the unit, the degrees, on the outside. So don't let the parentheses freak you out, is what I'm saying. We're supposed to find x, y, and p. So let's start with x. It's here. We see it's a vertical angle, so I am immediately going to look across the channel there and see what our other value is. Good, we have a solid number. So we know that 5x equals 110. Okay, vertical angles. Now, this is where geometry leads to algebra, because we can see there's a perfectly lovely little equation that we need to solve for x, because we're supposed to find x, not 5x. So we just divide both sides by 5. And x equals then 22 degrees. I can do that in my head. Okay? So x represents an algebraic value. It doesn't represent this angle. This angle is actually 5x. So that's where geometry gives way to algebra. Okay, so we got x taken care of. Let's look at y. Here's a straight angle. So 2y plus this 110 should equal 180. Again, we've built a nice, simple little algebraic equation here. We double check it to make sure it's right. Yeah, these two add together and equal 180. Beautiful. So now we can just switch to our algebra brains. Swim the 110 over here. Eva, I'll explain to you about swimming fishes someday, but that's what we call it when we add or subtract in an algebraic equation. We call it swimming fish. It dates back to my 7th grade math teacher, my algebra teacher, so, you know, it's a story. 70, we cross that out. 2y equals 70. Divide both sides by 2, and we get y equals 35. I shouldn't have a degree sign there because that's not how many degrees it is. Y equals 35. These are both correct, by the way. And then P, we can see makes another straight angle with 110. So P plus 110, I'm squeezing a little bit. P plus 110 equals 180, so we can subtract 110 from both sides, and we get P equals 70. That's the third part to our problem. Yay. Okay? We could have also gotten that by saying that P has to equal 2y, y equals 35, so 2y equals 70, same answer, all right? For several of these, there are multiple ways to get to some of these answers. I'm showing you one way. If you see another way, that's fabulous, absolutely great. Okay, flipping. The next section is about absolute values. Absolute value problems are easy enough to calculate. Whoops, I spelled that wrong. They're easy enough to calculate. They're just kind of weird mentally what they represent. The best way to explain is to draw a number line and to put in a 0 at the middle. Whoops, positive 1. Draw in a few values. And then let's go to the negative side. Okay, the idea about absolute values is that we're measuring the distance. Absolute value measures the distance from the number that we're discussing to 0. So let's take, for example, the number positive 4. If we want to measure the distance from 0 to positive 4, the value is 4. However, if we want to measure the distance from -4 to 0, sadly that's in the way. That's why my picture looks weird. If we want to measure the distance from -4 to 0, that is also 4 units. That's why we say that the absolute value of +4 is 4, but the absolute value of -4 is also 4, because absolute value measures the distance from a number to 0. Okay, that's what absolute value does. Puffy cloud of knowledge means that that's an important idea that we want to hold on to. All right, so that's why absolute value is always positive. Because it measures the distance from that number to 0. Okay. John has a bunch of other confusing stuff in there. We're going to skip it. Sometimes words make math worse. The numbers are almost always easier to understand. So let's jump into some numbers. Ready? Our instructions are to simplify. And we have one of these longish chains. Remember, these straight lines are the absolute value symbols. They're just perfectly straight lines. And I usually exaggerate them in mine so that you can tell it's not a 1. -2 plus. Okay. So the first step in these is simplify the absolute value numbers, okay? So anything in an absolute value sign, I'm going to change to its correct form. I'm going to simplify it. So I'm going to cover up this minus sign, and I'm going to say the absolute value of -4 is 4. Look, we did it right there. But when I take my finger off, that minus sign is still there, so I put that back. -2, that I copy, it stays the same, plus, and then here we have the absolute value of -5, that would be +5. Now, I have something that I can easily put together. I'm going to combine the negatives, so -6 plus 5 equals -1. Final answer. Yay. Okay? So that's the kind of absolute value problem you're going to see in the homework. I'm skimming the next lesson quickly because there's a lot in here that I don't want to get. It's a lot of theoretical stuff. He's talking about the difference between properties and definitions. Properties describe the way something is. Definitions are things that we've agreed upon. They don't like inherently make sense, but we've all agreed on how to treat them. And exponents are a great example of definitions because we've just agreed there's a certain way we're going to do exponents, and it isn't necessarily logical just by looking at it, but that's how we've agreed to do it. So let's jump into that example and skip all the theoretical stuff. John gives us instructions to simplify. Again, I write down the instructions so that you can see. I don't necessarily think you need to do that in your homework. All right, but I'm going to copy down the whole thing. And I do recommend in the beginning that you copy it down just like I'm doing, instead of simplifying in your head as you copy it over. That's just looking for trouble. Copy it like this, straight out of the book, and then start working. Okay, remember that the rule with exponents is that if there are parentheses around the number and a minus sign in there, that means, like in this example, we're actually cubing or multiplying by itself 3 times the expression -2. Not just 2, but -2. So this we would write as -2 times -2 times -2. Okay? Because the minus sign is inside the parentheses. It's protected, so it goes along for the ride when we do the cubing. So 2 times 2 times 2 is 8. 3 minus signs combine to make a minus sign, right? Even numbers go together, right? Two minus signs make a positive, but we have a third one, so our final product is negative. So that takes care of that. This minus sign is not protected by parentheses. So we're going to copy it down over here, and then we're going to cover it up and remind ourselves that this just represents 2 times 2, right? The minus sign is not part of that exponent. So that would be 4, okay? Minus, this minus sign is not part of the squaring here, so we'll cover that up. But here's another one that is part of the base. So that minus sign goes along for the ride when we solve the exponent. So minus 2 times minus 2 is positive 4. That's positive 4, but there's the negative sign that I've got there. Oh my gosh, it's so confusing, right? There's a lot going on. Okay, so that's what we came up with though, and when we add that all together, it becomes minus 16, and that's the correct answer. Okay? Especially once we get the hang of it, you don't necessarily have to write these out like I did, but it's a really good way to step these problems down a little bit and take information out of your head and put it on the paper so you can see what you're doing. All right, that is the end of lesson A. So let me remind you of how I want you to do the homework. For the first day of this week's homework, I want you to do lesson A, the odds. Okay? Everything, ooh, I'm just looking at, there are a lot of absolute value problems. You will probably cry and possibly hate me by the time we're done. Look at all of those. Oh my gosh. These are the geometry things that we did. Notice that there's no practice problems. It just goes straight into the problem set. We'll talk about practice later. But for this one, it's just problem set. And so you will do the odds on your first day of homework. And then on Tuesday, or whenever it is that you get ready to do your second session of homework, I'm going to have you do lesson A, the evens. Okay? Makes sense? So we get 2 days of homework out of 1 day's lesson, or one single lesson, because there's so much going on in that lesson. All right? And then just to give you a clear picture of where we're headed, this is all you have to do on Monday is watch lesson A and then do these 2 sessions. On Wednesday, I'll send you the link for lesson 2B, rather, letters, not numbers. And then we'll do the same thing. First, you'll do the odds. And then you'll do the evens. So that's 4 days of homework out of 2 lessons on video, okay? So this is your task for now. Do the odds and then do the evens. Don't worry about the practice set because there isn't a practice set in this lesson. And I will meet you back here on my Wednesday, whatever day you come, and we will do lesson B. Good luck with your homework. Goodbye.